Well, thanks. My name is James Caad. I'm a PM at the Developer Ecosystem and Platform Group at Microsoft, and I've been working with partners to help them build native Windows WebRTC apps for about 4 years.
And I'm Vlad. I work for a team that is called Commercial Software Engineering, and we work with the top Azure partners, Azure customers, Microsoft customers, and help them building solutions on Azure.
Great. So, quick disclaimer. Today we're talking about native universal Windows apps. That's the Windows 10 application platform. We could talk about that in a bit. We're also talking about Azure services, but we are not Edge. That's a different group. So what is the Universal Windows Platform? Briefly, if you haven't heard of it, it's the native platform for Windows 10, and it runs anywhere that Windows 10 does. So that would be desktop, HoloLens, Xbox, mobile devices, ARM and ARM64 laptops, and IoT. So we noticed that WebRTC native app usage was increasing 4 years ago, and decided that we needed to fill that gap for the Universal Windows Platform so that people could build WebRTC apps on UWP. So the UWP API surface is also language agnostic, so you can write apps for it in C++, C#, JavaScript, Python, any supported language. And to build this, we forked Google's Win32 native stack and moved it over and optimized it to support UWP. We did work to optimize the video pipeline for low-power devices. We added hardware AEC and AGC for audio. And we also maintained all of the features of the Chrome stack. So it's got all the codecs of Chrome, all the features, including SVC and simulcast, data channel, everything is there. So happy to announce today that after 4 years of maintaining a fork on GitHub, we've been discussing with Google the possibility of submitting this back to the webrtc.org repo, and we're working on that now. So the caveat is that there's no guarantee we'll get 100% of the way there. We're mostly using the public submission process, so we're going through reviews just like everyone does, but that's our goal. The UWP specific changes are going to live in SDK contrib windows, so we'll have our own little area to contribute this back, and Microsoft has committer rights there to accept CLs, so we'll be able to keep everything moving there. Google has also agreed to stand up UWP build bots, but we've agreed to keep those tests green, so that's on Microsoft. So just wanted to say thank you to Google for that opportunity, and we look forward to the collaboration.
Yeah, and one more piece of work that we starting now is a Unity plugin, a WebRTC plugin for Unity, because we learned that a lot of partners building games and non-gaming apps, and especially for mixed reality, which is about HoloLens basically for us, they need this, and they kind of trying to leverage different plugins that exist, the different builds, including UWP build that James's team was working on. And so we want to make that plugin in a Unity way. So we want to make it friendly for Unity developers and let them leverage things like using any texture as a video source, and vice versa. Once you receive a remote stream, you can basically project it to any mesh and do the same for audio, do post-processing and pre-processing on the device. And it's very important for them to have that kind of flexibility, because get user media is a great thing, but in a lot of cases, Unity developers and graphics developers in general, they would love to control that thing. And for some situations, like for ARCore or ARKit-based apps, they have to be able to inject frames into the pipeline, and that's what we want to let them do.
So a couple of additional announcements today. We've been working with Callstats to bring that integration to UWP apps. So we're making it easier for UWP app developers to integrate with callstats.io. We're going to provide a sample based on the peer connection app that demonstrates how to accomplish the integration. And we're also shipping a NuGet package to make that faster for developers. So we're excited to see how that can benefit HoloLens and Xbox devs. And that's just the first part of our collaboration with Callstats. So looking for more advanced scenarios in the future. We are also adding UWP support to the kite test, thanks to Dr. Alex. So that will be added along with all the other browsers and the native app platforms, and it will give us all of the compatibility testing that the other platforms have today. We're accomplishing that through with the app RTC sample, as is used for other platforms, and we're going to wrap that in a UWP container and shim it over to our WebRTC DLL. So thank you to Cosmos Software, and looking forward to that as well.
Yeah, and we want to share with you some stories from the customer perspective, because me personally just recently started working with WebRTC and trying different frameworks and libraries and infrastructure providers. And these are some of these things. They may sound like false for true and not quite true for you. But this is what we're looking like. This is how we see it from outside, and that's an important lesson for all of us working with real-time communications. The scenarios that our team is focusing on, they're quite special. It's not like about real-time communication in general. First scenario is cognitive processing. It's essentially about leveraging things like WebRTC for ingesting audio, video, and depth data into the cloud, so we can then run like multiple ML models on top of it and do other fancy things. Second scenario is about cloud rendering in real-time 3D streaming. You probably heard the announcement from Google about Google Stream, or from Xbox team announced Project xCloud. We're essentially doing this for many years now, and there is an open source product out on GitHub called 3D Streaming Toolkit, and that was kind of our starting point. Not all of those products that we're working on are using WebRTC, but 3D Streaming Toolkit in particular is using, and it's built for leveraging GPUs in the cloud for rendering like heavy scenes in real time, so you can then visualize it on mobile devices, including HoloLens. That was kind of a goal, and we open sourced that product, even though it's running in production for many of our customers. But the thing that we want to talk in the details today is remote assistant and shared experiences, because that's kind of HoloLens specific. And just to give you an idea, because it's not obvious to understand for people not working in that space what those two scenarios are. If you look at these four videos, and we start from like left topmost with these little red clouds, this is essentially people wearing HoloLens, and you can think about the camera that is recording them as another HoloLens device. So the thing that you can kind of guess that in order to render those three clouds for me as another user, as a third party, as like a fourth user in this scene, I have to communicate the pose of all those devices, all those peers, in real time to me, so my device can render it, and it will look for me like if those clouds were real. So we really need a low latency communication, and in the case of like the same room experience, this is what we call shared experience. That must be with the lowest latency and preferably real peer-to-peer communication. The second scenario, if you go on the right, that's kind of hybrid scenario. You see there are remote parties, those weird avatars, and the local users as well. And again, local, they communicate over like the same hologram. Again, all these devices, they render the scene, each device renders a scene. And so the state of this thing that we maintain is important to be consistent across all of them. And when you interact with this thing, when one user interacts with this thing, that interaction happens immediately, not on his device or her device, but also across the entire room, if you call it this way. The one that is on the bottom is a bit easier, even though it's not HoloLens only, it's across devices, you can see phones there. But there's just another example, and this is why we believe that WebRTC, like even for applications, should have a converged multi-platform SDK, so we can leverage this one scenario without writing code for each platform separately. And that's just one great example where we use multiple devices across platforms. And the last one, when you see like people interacting with electrical, I don't know, box, whatever, this is just the remote assist scenario when we have a user wearing a HoloLens and doing some work, and then there is a remote party helping that work. And actually, that remote user can create holograms and can add things in the scene in real time, and vice versa. When I do something here wearing my HoloLens, that the remote party can have all this state and can render it remotely, so like the scene looks in the best possible way. So these are kind of cases that we are looking for. And one of the challenges that we face, like one of the biggest challenges that we face with using WebRTC, is that we literally have to synchronize data that we're sending, data about the scene state and about the device pose and others with the video stream. And you can see when we use a custom RTP header extension, it's perfectly fine because every frame comes with the device pose. When we communicate it independently, essentially, with data channel, you see how choppy these things are because it's very hard to synchronize. Even when we have a low latency, we should take care of the actual synchronization between the packets that we receive and the frames that we display for the user. And the platform-wise, we solve this problem. Essentially, on HoloLens, every frame that you receive from a color camera has a device pose information, but we still need to have a way to communicate that. And if you look at the overall picture of the challenges that we have, first, as I mentioned already, every device has a world replica, that virtual world replica. So we have to communicate it with lowest latency, and this is where WebRTC is just the perfect thing to use. Obviously, given that we're talking about mobile devices, we have to do a lot of mixing, sub-mixing, simulcasting, because we would love to minimize the overhead that WebRTC brings, so devices can actually have some GPU and CPU for rendering scenes, because we're talking about 3D graphics here. And at stream synchronizations, we don't have many options there. We need it desperately. We were thinking about embedding data into video frames, and we've seen some people doing this, like you're literally embedding data into color frames, and then you just reserve some space in the color frame to communicate that. You can do RTP header extension, but that makes your WebRTC implementation essentially not standard compliant, and if one of the parties is a browser, you cannot leverage that. WebRTC stats, we had some ideas around that, how we can make it happen, but honestly, we haven't seen a real implementation of that is using that for synchronization. And unfortunately, there used to be RTP data channels, but now they deprecated that this is not something we can fully leverage. So if you have an idea, or you're actually working on WebRTC implementation that and WebRTC standards that can bring some of these capabilities to the standard and to the platform, we would love to know your feedback, and would love to influence the work that you do, because it's really important, not just for Microsoft, but for any companies that work on augmented or mixed reality scenarios. Just from the customer perspective, it's not related to mixed reality scenarios. The things that we face as a third-party view to the industry. First, if I'm a customer, a commercial customer that is trying to deploy a real-time communication solution, the deployment cost for myself is extremely high. Essentially, I have to hire a consulting firm for that. And that's something that bugs them a lot. And even if I deploy it, I have to still keep that consulting firm working for me, because I have to maintain it, I have to take care of the virtual machines, I have to monitor it, because all these solutions, the majority of those solutions, they don't provide these capabilities to me out of the box. And even though with all these things, if I figure them out, it's still an unmanaged solution in a cloud terms. If you think about the cloud services, it's an unmanaged service, because I have to babysit it all the time. Authentication of people graphs. Maybe it's just Microsoft customers, but they kind of used to situations when they deploy something, it's already integrated with their authentication system, with the what we call people graph, essentially like groups of people, the way you manage it across organization. And the mature solutions like Twilio, they have integration points with all these things that corporations use. But even though with that, our customers give us feedback like, we would love to just have it out of the box. We deploy it, we provide all the client secrets and authentication points and integration points just magically works. That's what they need. And it's not really that much to be done. I understand that everyone is trying to make their solution as flexible as they can, but for certain biggest providers of authentication and people's graphs, they just would love to have it out of the box. Privacy, that's again a cloud-specific thing. That big companies, they're quite resistant to the cloud, and to public clouds in general, but even when they come, they say, oh, I want to have like my own tenant. If you provide a software as a service solution, I want to have all my data in a kind of separate tenant, and the authentication that must be against my system. So like, don't mix me with other people. So even if you provide the software as a service, like communication platform as a service solution, they want you to run their stuff separately. Not in a physical form, and sometimes it's really on the physical service, but more on like the way where you store the data. I want my data to be stored separately. Data pipeline, that's again specific to customers that I work on and my team works with. The entire real-time communication industry, for a bunch of reasons, pivoted towards video and audio. What customers want, like, give us more ways to communicate the data, because we don't want to use WebRTC for video and audio, and then for data synchronization, use something else. We can, but WebRTC is just such a great thing in terms of communication in general. Why don't leverage that? So, like, give us more samples, give us more best practices, like whatever. Just let us use it. And in general, and this is what we would love to work on with the entire community, with other players and Google, it's just fixing WebRTC as an app framework. We would love to have WebRTC, if you want to say library, converge across platforms with the same public API, and not just in the browser. Because if you are a web developer in Chrome, you're in a very good shape. Chrome lets you do a lot of fancy things, and the stuff that I've seen today with Chrome going forward, and WebAssembly, and all these things, it's just amazing what you can do. Once you're out of the browser, you're screwed. That's what we'd love to fix. One partner that I just wanted to shout out is SignalWire. It's quite a new player, even though the free switch is out there for many years. What we like about them, they build the communication platform having developers in mind first. They're building like the platform that has APIs first, and they're trying to fill that gap between video and audio people first, and then the rest of the world. So they're trying to fill that gap, and we just appreciate that. And the one more thing that I personally like, and looking out there, I haven't found many solutions that leverage GPU, especially GPUs in public clouds, because these things like video encoding and decoding, these are like obvious to be done on GPUs, and more customers are willing to pay for GPUs. But when their communication solution cannot leverage that, it's kind of weird. So if you're thinking about using that and building into your solutions, mostly on the software and platform as a service sides, please do, because we have customers who need it and who would love to leverage, and NVIDIA actually would appreciate it as well, as you can guess. So that's one of the things that these guys are doing.
So this is a kind of a look under the covers of WebRTC, UWP, and ORTC. And just wanted to mention that we support ORTC as well for those scenarios, and that they leverage the shared WebRTC core in C++, which is Google's code. We then have defined an API surface in intermediate definition language. It's originally a Microsoft format for IDL, but it's now standardized as MIDL3. And from that IDL, we then generate API surfaces for all the different platforms we support. UWP is the C++ WinRT piece that we mainly focus on today, but we also have generators available for Xamarin, for .NET Standard, and for Python support. So a lot of these things are in the works, but just wanted to give everyone an idea of what's available.
Yeah, there are some links that we want to give you like as more like action items. So if you want to try, first there are 2 emails. If you want to work on something, want to share feedback, or not specifically about the UWP of WebRTC, but like the work that you do and you would love us to do in general, these are our emails. I haven't asked James to put his email, sorry.
No, that's good.
Then obviously the links for the implementations that we're working on, the tree streaming toolkit, some pieces that we made for customers and made it open source to make our deployments of WebRTC enterprise ready. And the last link.
Yeah, the last link is a survey. We're interested to know what WebRTC developers use for your dev box. What tools do you prefer? So if you're interested to provide feedback, there's a link to send it.
And then we're ready for your questions. If
Thank
there
you.
are ones.